Put a couple more kinks in that. Let's get the key on there. We're almost there. I could work with that more, and I probably would if this were a real repair. I'm just doing this to demonstrate, and I don't want to take all night doing it. But let's say we've got it real close. We're going to put the rod that we're using on the key instead of the wiggle rod in the chuck, and we're going to lap it in a little bit. Lapping is using an abrasive compound, and what we're going to do, I've got a bar of lava soap that has pumice stone in it. I'm going to put a little oil on it, rub my finger around in that and make a little paste out of the pumice stone. Put that on the rod, and we're going to lap the key to that. The way lapping works is the pumice stone, whatever the lapping compound is, whatever the grit is, sticks to the softer material and slightly abrades the harder material. So it will actually stick a little bit inside this brass alloy key. That's silver plated. It's probably a nickelized brass, but that's going to be a little bit softer than the steel. So it'll actually remove a little bit of metal from the steel. And I want to put it in there the same way that the rod works in the key when it's there. So we're going to go this way instead of that way. And then a high rate of speed is how lapping is done. I'm just kind of pulling that key around different pressure on that, different directions. And I can work it that way. It's still not real free. But I could continue along those lines until I get it real free. The wiggle rod does stretch the metal. It straightens it somewhat. It also stretches the diameter of it. It also will stretch it in length a little bit. So we'll probably try it on the oboe and find that it no longer fits between the key posts. And that, well, it does. Sometimes you have to trim a little bit off the ends, and we'll show you that in a bit. So let's say we've done all this and we still can't quite get it to fit. We still have another option. We could make a new rod of a slightly smaller diameter. We could use some fine sandpapers on this rod and try to sand it. We could figure out just exactly which area is sticking by where it fits in the key and sand a little bit with fine sandpapers. We could also ream the key out a bit, and I'm going to show you that now. The pumice stone continues to break down into smaller and smaller particles. One problem with lapping grit is it tends to stick in the key and continue to wear on the rod over the years, but the pumice stone breaks down more and more over time. And so it has a little less of a continuing to abrade the parts effect on it. Any decent repair shop's going to have some sort of fancy measuring devices. These are rather cheap. 20 bucks will get you one of these calipers. This one's both metric and inch. I'm going to measure this rod and see what it is. It measures 77 thousandths of an inch. I've got a set of reamers, precision machinist reamers. Any machinery supplier has these. J.L. Smith and Company has them, one of our main woodwind suppliers. The rod's going to have to fit with at least a thou, if not a couple thousandths of clearance, so it doesn't just stick. You need a little wiggle room so it can move freely, and room for oil. So I have a reamer here that's 78.5 thousandths. We're going to try that. We'll see how it fits in the key. It's a little bit snug right where it's bent. We might have to go up a size. I'm not going to run this under power. because the reamer will heat up and expand a bit and stick, and then it'll score this, scratch it all up, and it'll be real hard to get it apart. See, that just goes on there all the way. It's kind of, when it goes on there, it's kind of straightening out the key, kind of, or flexing with the key a little bit. So we're going to go up a size and show you that. If this were a real repair, I'd work with it a little bit longer, try to get it straight more. I'd rather do that than to remove metal if I can help it. So I've got a reamer here that's 81 thousandths, and that doesn't quite go. So we're going to try that. Put a little oil on it. And just run it in there by hand till we're all the way through. I don't normally have the lathe in this position. I did this for the video. It's starting to stick a bit. My lathe is not mounted very securely here. I just got it attached to a kind of a skinny board so you can see it wobbling around. I'm going to pull it back off. It's starting to stick pretty good in there, and that's sometimes a problem. I'm going to wipe off the chips and re-oil and keep working it like that until it's all the way through. Okay, I worked a little bit more with the reamer, and I also did a little more straightening with the rawhide mallet. I got that working pretty well now. The spring tension would take care of that. That should really spin on that, but I don't want to take all the time in the video showing that. So that's pretty much basically the methods of key straightening. The rawhide mallet, the wiggle rod, the hole in the handle of the mallet. You can sight down something like you're looking down a rifle barrel. I saw a blacksmith once trying to straighten a rod, and she was looking down it, holding it up to the light and looking at it different ways. It may look straight in one direction, but you turn it and you can see that it's bent somewhere else. I can kind of see that here. It's bent a little bit right down here. And that helped, just flexing that a little bit right there where I saw that it was bent. So that's key straightening. Next we're going to talk about swedging or fitting the keys. In order for pads to seat well, they have to hit consistently in the same spot on each tone hole. So you don't want keys moving around between the posts very much, and you certainly don't want lateral movement where they can move kind of side to side on the rod. All the posts and keys are connected to the wood, which is not a particularly stable product. Wood expansion and shrinkage is mostly radially around it. There's only like 1–1.5% of movement lengthwise. So the keys in this direction can be fit fairly well, because if the wood swells, things aren't likely to stick on keys where the rod goes vertically as you hold the instrument. If you swedge things too well on the horizontal keys, like the first octave key, it could stick later if the weather changes, or if the wood hasn't been oiled in a while and somebody starts oiling it more. So I like to leave just a little wiggle room on the first octave key, but it shouldn't be flopping around too much. These keys can be fit better, however, gravity tends to hold them down to their lower position, or it's not all that critical. They're likely to hit about the same way each time, but you don't want any real bad movement between posts and between keys. You do want to avoid any lateral movement where especially these little pads here, the C and B flat can tip different directions. This little C key is pushed on here under this adjustment screw and also here. So with different fingering combinations, you might get a little bit different tip to the key if that key is not fit well to that rod. Down here, I think on this Yamaha oboe, that's a long rod through there, yes. So that kind of holds it more securely. On most oboes, you have a little pivot screw here, and they can be problematic for a nice fit. And you'll get a little different closure on the C key depending on whether you're using the C key or it's being pressed over here with the C sharp. So that's kind of a critical area. You've got a lot going on here where things can tip differently, where there's just a lot of, wherever you have a lot of adjustment screws are areas where things might tip differently depending on upon the fingering combination. So places to look, you just don't want any real noticeable slop anywhere. One spot is this first octave, especially if it's ever been cracked through there. That can spread the distance between the posts. It's critical here. Make sure there's no lateral play there on those little pads, on those little keys. This area here is fairly critical. Those pads are the hardest to put in and get right, and you're fighting a losing battle if you're changing these pads and the keys don't fit well. And then this spot right here at the top of the C post, that rod or that pivot screw has to fit especially well. This oboe has some play here. There's no pad attached to that key, so that's not so critical. The side F key tends to have quite a bit of play in it over time. It's such a short little hinge tube that it wears quickly from the pressure on that. I'm going to show you some various little swedging pliers that I have. We have on this old oboe, I don't even know what this is, we have a little wiggle here, a little more than we need on this first octave key. So we're going to pull that rod. Sometimes you can even feel that the rod doesn't fit well in there. It's good to clean things off before you start using the swedging. Swedging is a blacksmith term, maybe mispronounced from the word swage, which means to squeeze metal to shape. Use a pipe cleaner to clean this out. And this is my favorite swedging tool if I can use it. It's got a little collet in there. This is available from Faree's Tools. And I would hold this in a vise generally. And swedging is always done with the rod in the tubing. So what we're going to do is squeeze the tubing down to the rod, to the rod so it can't wiggle around on the rod. And you can put quite a bit of pressure on that, especially if you hold it in a vise, and kind of turn it on there while pulling it off. And you can do it on the other side as well. I've got other pliers. This was my first pair from Faree's. They've got little holes for different size hinge tubing, and it's got a hole on the end as well. And you can put that on there, find the one that fits the best. It's a good idea to wipe off the jaws and maybe put a little cork grease on there. I've got this bigger pair, which is good because you've got more leverage and you can put more pressure. It can take quite a bit of pressure, but you want to be careful not to over swedge too. And just kind of turn it around on there. You can also, it tends to kind of scratch the plating a little bit. It's usual to see that on an instrument that's been fit well. And I just swedged it to the point where it's a little too tight now and sticking. You can use the wiggle rod again to open that up a bit, or a reamer. You can use pin gauges. You can measure this rod and use a pin gauge, which is a machinist's measuring tool. I've got a box of those here, and they come in every thousandths of an inch. So it's just a very precisely ground piece of hardened rod, And so you could use a piece that's a thou bigger than the rod in the key. That way you can't possibly swedge it down to where the key would stick on the rod. The first thing that happens when you swedge is the hinge tubing will go down to the size of the rod. And beyond that point, then it has to go, the metal has to go somewhere as you continue to squeeze, so the tubing will stretch out lengthwise and fit more snugly between the posts. So I would work with that, and you can use the lapping compound if you over swedge, and that way you can get it fit better between the posts. If you do get it stretched too long, there are some tools you can use to shorten it. These are hinge tube shortening tools. It's got 4 cutting edges on it and a pilot that fits in the hinge tubing. This one's a little too big, but that would fit in there, and you can trim down, turn it around against the edge of the end of the hinge tubing and shorten it up again until it fits just right between the posts. And that's key swedging. Okay, I've got my jeweler's lathe set up with this little cross slide on it. It's got parts that move with a screw thread so that I can put this cutter against this brass rod. Let's say you've got so much play on the key between the posts that you want to solder a little extension on there. I don't know what I was doing this. It looks like it's got a little super glue on the end there. I'm going to first take what's called a facing cut on the end of this to clean that up. And then I'm going to make just a little small extension on there that will fit inside the hinge tubing. Got to go just a little bit more. There are micrometer markings on these handles on this little cross slide. If I wanted to use those for my measurements, I could know exactly how much material I'm taking off of this piece of brass. And I would just do that until it just barely fit in there. And then I'd saw off a little piece. I'd solder it in place. And then I would run a drill through the other end so that the hole went all the way through, and then I would have a little washer soldered on there, a little extension on there. You can also, and that would be permanently attached to the key. You can also buy little plastic washers or make them up in a drill press. J.L. Smith has little washers to fit in things. They work well, especially for a temporary fix or on a cheap student horn that you don't want to go to this trouble on. But the first time you pull it apart, the washer's going to go flying somewhere, and you'll have to replace it or find it on the floor. To make up washers, I've got these little brass telescoping tubing in all sorts of sizes. That you can just run in a drill press and hold a file or sandpaper and sharpen them up. You can use a sheet of kind of thick hard plastic available as shim stock for machinery suppliers, and spin this in a drill press through the plastic and make a little hole, and then go up a size and make a kind of a donut shape out of the plastic by using 2 different sizes of these, and you can make yourself up a little plastic washer. You can also use Teflon tape. Here's my Teflon tape. This is available. It's a plumbing supply as a sealant in threaded plumbing pipes. And it's not really like a tape. It's not sticky, but it does kind of cling to itself. And you can make a little thread of this up, kind of wrap that between the key and the post, say here. If you had play, let's say right here, you could kind of fit some of that and wrap it around there and kind of tuck it in, and that can help hold the key from moving between the posts. If I'm going to do any swedging or something like that, it's probably best on these vertical held keys to do that on the top end, because the pad's probably wanting to hit when the key's in its downmost position, because gravity's going to pull it down. So do your work at the top end of these keys that go in the vertical direction, and it may avoid having to change the pad. If you change the fit of the key in such a way where the pad's hitting a little bit differently, you're likely to have to change that pad in order to get it to seal correctly. If you have a row of keys and posts on a very worn instrument, it may not be worth saving, but if you wanted to, there's a little jig available that you can line up on the posts with the keys off, and these things move about, so you can tighten them up against the posts. And then I have these extra long drills